Good afternoon, class. Thank you. You can sit down. All right, then we'll have to look at the homework first that you were given last lesson, and then we'll discuss the formulas for finding the volume of certain solids. All right, then we looked at 1A already. All right, the answer, if I can remember, the answer for that was 62.4. All right, and we have to continue and look at the rest of the questions. There were 4 questions that you were given. So for letter B, Kiapin, can you give us your answer to letter B, please? And if someone disagrees, just put your hand up and then we can have another answer. 108 or 180?
180, sorry.
Okay, 180.5.
0.4.
0.4 square centimeters. Okay. Anyone disagrees with that? No? Say, letter C. 1C. Esther, your answer, please.
324 square centimeters.
324 square centimeters. Anyone who disagrees with that answer? No? All right, 2A. George.
$368 square
368
square centimeters.
square centimeters. Letter B. Raylene. 2B.
Eight 880 square centimeters.
880 square centimeters. Is that correct? Yes. All right, letter C. Boromeo.
Oh, 858 square centimeters.
Okay, 858 square centimeters is correct. Letter D. Velma.
$120.64 square centimeters.
200 and
420.
420.6. $420.64 square centimeters. Any challenges for that one, for that question? Or you all agree? Solomon. Huh? Is it the same? Anyone with a different answer? Geno?
$118.64.
200 and?
418.
418.64. Anyone else with a different answer apart from those two? Peter, what's your answer? Same as the first one, 420.64. Okay, let's see. Excuse me. The surface area is equal to, because it says it's a closed figure, it will be pi r squared, which is the area of the base, plus 2 pi r h plus pi r l. Okay, which is pi r plus 2h plus l. Because 2.8 is a multiple of 7, we will use 22 on 7. So 22 on 7 times 2.8 times 2.8 plus 2 times h is 20 plus l is 5. Okay, I get 8.8 here. And I get 40, 45, 45 plus 2.8 is 47.8. Please correct me if I'm wrong. Correct? Okay, so 8.8 multiplied by 47.8. What do we get? 420.64. Okay, if you have a different answer, check where you've made the mistake. All right, that's question 2D. All right, 2E. Chutaili, your answer for 2E, please.
One hundred and 1.6 to 1 decimal place.
Okay, 201.6. Did you say 201.6? And that's to 1 decimal place. Any other answers? Oh, you all got the same answer? Keela?
What? 201.4 square centimeters.
201.4.
4.
Any others apart from those two? Natasha?
Yeah. 193.6.
193.6. Any others? Excuse me. Vui, same as 193.6. Any that's different from these three answers on the board? No? Okay. The figure is made up of a cone, NA, sphere. Is it a hemisphere or a whole sphere? A hemisphere. So the surface area will be equal to, note it's a closed one, so it's pi RL plus half of 4 pi r squared. Correct? Okay, so we are given the perpendicular height. We don't know what the slant height is. So we have to find the slant height using 3.5 and 10. Okay, so that's L. L is equal to the square root of 3.5 squared plus 10 squared. Okay, very quickly, what is that equal to? 3.5 squared plus 10 squared. Get the sum, find the square root. 5.10.6. Okay, so That's what we have to substitute here. Pi is 22 on 7, since 3.5 is a multiple of 7, multiplied by 10.6, plus half of 4, which is 2. So I'll just say 2 times pi, and r is squared. Okay, sorry, this is the slant height. Okay, so what do we get when we add this? The first one, pi RL, 22 on 7 times 3.5 times 10.6. 116.6. And this one, 77 to the nearest whole number. Exactly 77. Okay, so 116.6 plus 77 is 193.6. So this is the correct answer. Next one, that was 2E. 2F. Then, can you give us the answer for 2F?
$720.06 square centimeter.
720.06 square centimeters. Siegfried, do you have the same answer as Dan? No, okay, what's your answer?
$774.4 square centimeters.
774.4 square centimeters. Any other answers? Kyle? Oh, you didn't complete it? No? Gabriel? 774.4. Do you want us to do this one? Okay, it's very similar to letter E, except that the radius for this one is, what's the radius? 7. Unless you've used a different one. You do exactly the same. You have to find the slant height because the perpendicular height is 20. So the actual correct answer is 774.4 square centimeters. I'd like you to do this for yourself because I've done 2E, which is very similar to 2F. They're the same type of figure. All right, number 3, your answer is supposed to be 124.8. Okay, if, because it says a church tower is in the form of a cuboid surmounted by a square pyramid, as shown in the diagram, what area must be painted? The tower will not have a base because it's on top of a building. So you're supposed to exclude the base. So the base is not painted. That's why it's 124.8 square meters. If you've included the base, then your answer is that plus the base. It's a church tower, and a church tower is on top of the building. That means the base is not there. You agree? So it's only the top, so the base is not included. Let's just check if that answer is correct. There are 1, 2, 3, 4 4 sides, correct? Okay, so the surface area is 4 times 6 times 4. Okay, so those are the 4 faces. 1, 2, 3, and the back will be the fourth one. Then the 4 triangular faces at the top. All right, 1, 2, 3, 4 at the back. Now, we need to find out the perpendicular height for one of the faces. Okay, the triangles are isosceles triangles, if we all agree. And this is 4. We have to find the perpendicular height to one of the faces, and then we can find the area of one of the faces and multiply it by 4. Okay, we know that from here all the way up is 9. So the height from the middle of the pyramid there to the top is 3. But that is not the perpendicular height of one of the faces. It's the perpendicular height from the middle of the pyramid to the top there. But it's not from here to the top. It's from the middle here. Can I just draw it in? Okay, what I'm saying is that sorry, mine is not really a good one. Okay, from the top, because you are told that from here to here is 9. Is it in meters? Okay, if it's 9 meters, from here to here is 6, which means from the middle here up is 3. But from the top to this is not 3. It's different. So what you can do is you can actually find the length. Okay, from here to the middle, because this is 4 meters, from here to here is going to be 2, and then 3. To find this, you'll have to use Pythagoras Theorem, which is, I'm going to call the perpendicular height to one of the faces h. It's 3 squared plus 2 squared. And that's 9 plus 4. Is it the square root of 13? 3.6. So without the base, it's 4 times 6 times 4. That's 4 faces. Look at the diagram on the screen because it's a better looking one. And then plus 4 times, there are 4 triangles. So it's half of 4 times 3.6. Okay, so what's 4 times 6.4? 24 times 4 is 96. 96 plus, that's 2 times 8, 8 times 3.6. I just got 4 divided by 2. I got 2. 2 times 4 is 8. 8 times 3.6. So it's 96 plus what? 28 point? Sorry. So it's 124.8 square centimeters. Square meters. So note for that one, there is no base and there is no, the top of the cuboid is also not there, because that's the base of the pyramid. All right, number 4, please check your answer as well. 1,496 square centimeters. It's the curved surface of a cylinder plus 1 hemisphere, because there are 2 hemispheres at the end, both ends. Is that correct? 1,496 for question 4. Any questions? No? You want me to do number 4? Okay, no white chalk. Okay, area is equal to 2 pi r h plus 4 pi r squared. I just, because it's got 2 hemispherical ends, I just made that 1. So it's 1 hemisphere plus the curved surface of a cylinder, because that's what it says. So it's 2 pi r h plus 2r. So 2 times 22 on 7 times 7, h is 20, that's the length, plus 2 times r is 7. So I get 44. 14 plus 20 is 34. 44 times 34 must be 1,496. Correct? Okay. We're now going to look at volume of certain solids. Okay, I've got the volume of solids and the volume of liquids, and I've just defined the volume of solids as the amount of space that that solid occupies. Okay, the units that I use for solids will be, what's the first one? Lester? Units that I used for solids.
Cubic millimeter.
Cubic millimeters. Patrick, the next one.
Cubic centimeters.
Cubic centimeters. Livingston, next.
Cubic meters.
Cubic meters. Okay, and you can also use cubic kilometers, so on, but these are the main ones. Usually cubic centimeters and cubic meters are the ones that I use more often. Okay, for liquids, I've just said the volume of liquids is the amount of space the liquid occupies in a container. You all know that. Okay, units that are used are, Agnes, for volume of liquids.
Milliliters.
Okay, milliliters. Garanamo.
Liters.
Liters. Miriam.
Kiloliters.
Kiloliters. Okay, and so on. Those are the units that I used for liquids. Okay. The general formula for finding the volume of solids, or the volume of, I've just put down prisms, is equal to the area of the cross section. And I'm going to explain that. It's usually the area of the front face, or the area sometimes of the base. So it's the area of the cross section, and you multiply that by the height of the prism. Sometimes if the prism is lying down, then you multiply that by the length and not the height. So it's sometimes the cross section multiplied by the length in some books, if you have a look at some of the books that I used. All right then, so generally the volume of any prism is, or any solid is given by A, which represents the area of the cross section, multiplied by H. Like I said, sometimes you might be given A times L. Okay, I've just done an example here on a very irregular solid. All right, and I've shaded the cross section of the solid. Okay, the volume is equal to A times H, like this one. Instead of H, the length here is 8, because it's a, it must be a house, a model of a house, I don't know. Okay, so the area of the cross section here, and the cross section here has rectangle and a triangle. So the area of the rectangle plus the area of the triangle, which is the area of the cross section, and then we multiply it by the length. So I've got the area of a rectangle, which is 4 times 10, 10 times 4, and the area of the triangle, which is half of the perpendicular height there is 5, and the base is 10. So I've got 5 times 10 over 2 multiplied by the length. So I get 65 times 8, which is 520 cubic centimeters. Okay, so generally, sorry, cubic meters. So generally, the volume of any prism or any solid is given by the area of the cross section multiplied by the length or the height. Okay, this is what I want you to come and do now. Because you are familiar with these are the volumes, we are going to look at the volumes of the certain regular solids, okay, and very familiar ones. You're going to come to the board and explain the volume or the formula for the volume of a cuboid, a cube, a cuboid, a cylinder, and a cone, and a pyramid. We have plenty of time, 5 minutes. So I am going to call you out and you come and explain this. And then I want you with the red pen to shade the cross-sectional area, the cross-section area. And this, if I didn't draw properly, you redraw it and put in the cross-sectional area. Okay. The first one for the cube, Daniel, a cuboid, Megan, cylinder, Hekoi, a cone, Vui, and Jake, the pyramid. All right, first one quickly. You don't have to take so much time. Who's first? The volume of a cube. You come and write the volume of the formula on the side and then shade the surface, the area, the cross-sectional area. Okay, Daniel, number 1, please. A pen, use a pen. No. Use the red to shade in the cross-sectional area and the blue to write the formula. Where's the mic? And here's the mic. Yeah. No, what the formula is. What do you mean? Not where you got it from. You got it from the book. How you get the formula? Yeah, shade the cross section. For the pyramid, it's just the base. Which one is yours? Yeah. Yeah, I didn't just shade. Explain it. Mike there. Face the class or the camera. It's 1/3 of a cuboid. If it's a square pyramid, you can actually cut.
To get the volume of the cube,
three
you have to
pyramids from a
multiply the length,
cuboid.
the width, and the height.
If it's a square base, you can cut three of them from a cube. Right. You just go and explain them. Yeah, you get
To get the area of a cuboid, you just times length, width, and height.
this one here is no, it's okay, but usually I label.
To get the volume of a cylinder, you multiply the area of the circle by the height of, the height.
Next. Oh. Yeah. I meant not to warn you in this one. Turn around.
To get the volume of a cone, you multiply 1/3 times pi r squared times height. It's 1/3 because the cone makes up 1/3 of the cylinder.
To get the volume of the pyramid is 1/3 times the area of the base times the height. 1/3 is it makes up 1/3 of the pyramid makes up 1/3 of the base.
Okay, for a cone, as we said, a cone is actually 1/3 of a cylinder. You can, if you cut a cone up, you can cut if you cut a cylinder up, you can cut 3 cones from it. And circular base here is pi r squared. So it's 1/3 a times h, and a is pi r squared. For this one, it depends on the base. Like if this one is a square pyramid, then you actually can cut 3 pyramids from the cube. If it's a rectangular base pyramid, then you can cut 3 pyramids from a cuboid. And note A here represents the area of the base. So it's 1/3 the area of the base times the perpendicular height. Okay, you have an exercise to do. All right, it's 10 questions for next lesson. Sorry, 12. All right, and you also have a test to study for. Okay, the keyword to the pilot teacher is volume. Okay, stand up, please. Good afternoon, class. Thank you very much. You can go.